EMF and the motional EMF. Now I'll be introducing a new concept called displacement current. Okay, I'll just try to introduce this topic called displacement current. Let us just take an illustration of a capacitor which is connected to an AC source. It is just an illustration, guys, to make you people understand what is displacement current. And then later we shall come to the syllabus. Now just say current is flowing and this is an AC current and this is a parallel plate capacitor. Okay, and now if I try to place a magnetic needles here, magnetic needles are sensitive to magnetic fields. Here one on the above the conductor and the another magnetic needle between the capacitor or capacitor plate. Now if you carefully observe, when the AC current is on, when you trigger this circuit, there will be a current here flowing in the conductor, and this produces what? This produces a magnetic field. Here you can see there is a magnetic field which is produced around this conductor and which will deflect this magnetic needle to another point. Say like this, there is a deflection of this magnetic needle due to this magnetic field, and it's quite evident. Like you have a current carrying conductor, and this conductor will produce a magnetic field, and this magnetic field you can say line integral or closed line integral HDL is equal to the total current. The amount of current, total amount of current is equal to the total amount of magnetic field which is enclosed by the closed loop here. This is fine. This Ampere circuital law holds good in order to calculate the total current. Now, surprisingly, I could see there is a deflection of the magnetic needle here inside the capacitor as well. This deflection, as per the law of physics, you have the charges which were at motion. Charges at motion produced what? Charges at motion produces current, and the current produces magnetic field. Due to this magnetic field, there was a deflection. Then how do you explain the same concept here? Since there was a gap here, this was an air gap, this was empty, so there were no charges were moving, there was no current. Since there was no current, there was no magnetic field. There was no magnetic field here between the two parallel plate capacitors. Even then, there was a deflection. Right? There was a deflection. And how? And this concept of deflection was explained using the displacement current, or there was a rate of change of electric field from this plate to this plate. So the electric field was displaced from one plate to the other plate. There was a rate of change of electric field. We call it as displacement current. I repeat, This deflection was due to the rate of change of, so this concept was overcome, or this concept was explained in terms of displacement current, which is nothing but the rate of change of electric field causes the deflection, and this is causing you the deflection of that magnetic needle. That means if you have the varying electric field produces what? Varying magnetic field, and this causes the deflection of this magnetic needle. And guys, if I call this as a conduction current IC, and if I call the current due to the displacement as displacement current ID, I'm trying to rewrite the circuit here since I had a lot of information on that circuit here. I repeat, if I call this current as IC and this current as ID, can I call total current I in a given capacitive circuit is equal to what? IC plus ID. That means the total current I is equal to conduction current plus the displacement current. Again, if you measure the current here, it is IC only. This IC is equal to this IC before and after the capacitor. And can I say IC is equal to ID then? Conduction current is equal to what? Displacement current. Because there is no loss of current. In the positive half cycle, the capacitor charges. In the negative half cycle, the capacitor discharges, or there will be a displacement of electric field from one plate to another plate. And that is called as displacement current. And this is equal to what? The conduction current. Hope you'll remember this concept. Is that okay?